Welcome to the part 3 of our video presentation. This time, we will tackle the conditional and biconditional statement to be reported by Kathleen B. Orante, our tribe secretary, and yours truly, the tribe leader, Monet Lauderis Pindol.
Good day, everyone. I am Kathleen B. Orante from BSE 1G Tribe Fair Hypercalculum, and today I'm going to discuss about the conditional statement. In this lesson, we will explore the world of conditional statement. We will walk through the answers to the question like, what is meant by a conditional statement? What are the parts of conditional statement? And how to create conditional statement along with solved examples. So I hope you will learn a lot about this lesson. Let us now start with our lesson. So, we need to first define what is conditional statement. So, conditional statement is it gives condition in order for us to come up with a conclusion. That is why it is called conclusion. It is also a compound statement, which means it was combined. So, we have two statements, and those two statements are if and then statements. A conditional statement is a part of mathematical reasoning which is a critical skill that enables students to analyze a given hypothesis without any reference to a particular context or meaning. A conditional statement is a compound statement of the form if P then Q, where P and Q are statements. The first statement P is called the hypothesis and usually begins with if, while the second statement, Q, which is usually begins with then, is called the conclusion.
So, what are the parts of conditional statement? Conditional statement composed of two main parts. Those main parts are hypothesis, which is denoted as if, and conclusion as then. Hypothesis is a tentative assumption made in order to draw out and test its logical or empirical consequences, while the conclusion is the necessary consequence of one or more propositions taken as premises. It is also the result or the concept you gain from the hypothesis.
Here are some of the examples of conditional statements. Example number 1. If today is Monday, then yesterday was Sunday. The hypothesis in the statement is, if today is Monday, while the conclusion is, then yesterday was Sunday. In the example number 2, if a number is greater than 0, then the number is positive. The hypothesis in the statement is, the number is greater than 0, while the conclusion or the Q is, the number is positive. The next example is, if the base angles of a triangle are equal, then the triangle is isosceles. The hypothesis or the P in the statement is, the base angles of a triangle are equal, while the conclusion or the Q is, the triangle is isosceles. The last examples is 3 open parenthesis n plus 1 close parenthesis is equal to 6, then n is equal to 1. The hypothesis is 3 open parenthesis n plus 1 is equals to 6. The conclusion is n is equals to 1.
Now, let's identify the antecedent and consequent of a conditional. In any conditional statement, it is answered by if P, then Q, or by if P and Q. The P statement is called the antecedent, and the Q statement is called the consequent. So here, we have an example of conditional statement. Example 1. If our school was this nice, I would go there more than once a week. The antecedent is our school was this nice, and the consequent would be the I would go there more than once a week. Another example. If you don't get in that plane, you'll regret it. The antecedent is you don't get in the plane, and the consequent is you'll regret it. Third example. If you strike me down, I shall become more powerful than you can possibly imagine. The antecedent is you strike me down, and the consequent will be I shall become more powerful than you can possibly imagine. The conditional statement if P then Q can be written using the arrow notation of P and Q. The arrow notation in P and Q is read as if P then Q, or as P implies Q. Now, let's go to the truth table for the conditional P and Q. To determine the table for P and Q, consider the advertising slogan for a web authoring software product that states, if you can use a word processor, you can create a web page. This slogan is an example of a conditional statement. The antecedent is P, you can use a word processor, and the consequent is Q, you can create a web page. Now, consider the truth value of P and Q for each of the following four possibilities. First is, you can use a word processor and you can create a web page. If both of the P and Q are true, then the truth value of the advertisement is true. Second, you can use a word processor, but you cannot create a web page. The P is true and the Q is false. So in this case, the advertisement is false. Third, you cannot use a word processor, but you can create a web page. The antecedent or P is false, and the consequent or Q is true. Because the advertisement does not make any statement about what you might or what you might not be able to do if you cannot use a word processor, we cannot state that the statement is false. So, the statement is true. Fourth, you cannot use a word processor and you cannot create a web page. Once again, we must consider the truth value in any case to be true, because the advertisement does not make any statement about what you might or might not be able to do if you cannot use a word processor. So, we will place true. So this will be the truth table for the conditional P and Q. You should remember that the conditional P and Q is false if P is true and Q is false, and it is true in all other cases. So here's another example on how to find the truth value of a conditional statement. Example: if 2 is an integer, then 2 is a rational number. In this case, the consequent is true, so this is a true statement. Another example: if 3 is a negative number, then 5 is greater than 7. Since the antecedent is false, then it is a true statement. Another one is if 5 is greater than 3, then 2 plus 7 is equals to 4. In this statement, the antecedent is true and the consequent is false. Then this is a false statement. Next is the equivalent form of the conditional. The conditional of P and Q is equivalent to the negation of P or Q, and you can see that both of the truth values of each is equivalent to each other. Now, let's write a conditional in its equivalent disjunctive form. You should remember that the disjunction uses the connective "or". So, example of a conditional statement is, if I could play the guitar, I would join the band. In its equivalent disjunctive form, we will write the negation and disjunction of the statement, which is, I cannot play the guitar or I would join the band. Another example, if Cam Newton cannot play, then his team will lose. Its equivalent disjunctive form is, Cam Newton can play or his team will lose. Next is writing the negation of a conditional statement. The negation of P conditional to Q is equivalent to P and negation of Q. Example, if they pay me the money, I will sign the contract. Its negation will be, they paid me money and I did not sign the contract. Another example, if the lines are parallel, then they do not intersect. And its negation will be, the lines are parallel and they intersect. Now, let's go to the biconditional. The biconditional. The statement if P then Q and if Q then P is called biconditional and is denoted by biconditional of P and Q, which is read as P if and only if Q. P if and only if Q is equivalent to if P then Q and if Q then P. Next, let's write the symbolic biconditional statement in words. Let P, Q, and R represent the following. P, she will go on vacation. Q, she cannot take the train. R, she cannot get the loan. P, if and only if the negation of Q. The answer will be, she will go on vacation if and only if she can take the train. Number 2. Negation of R if and only if the negation of P. She can get a loan if and only if she does not go on vacation. Next, in this slide, you can see the truth table for biconditional. P if and only if Q. If both P and Q are true, then its truth value will also be true. If P is true and Q is false, then it is false. If P is false and Q is true, then it is false. If both of them are false, then the statement is true. Now, let's state if this biconditional is true or false. A. X plus 4 is equal to 7 if and only if x is equal to 3. Here, both equations are true when x is equal to 3 and both are false if x is not equal to 3. Both the statements have the same truth value for in any given value of x, so this is a true statement. B. X raised to 2 is equal to 36 if and only if x is equal to 6. If x is equal to negative 6, the first equation is true and the second equation is false. Thus, this is a false statement.
There are three related statements in order to check whether the statement is true or false. We have subsequent parts of a conditional statement, and those are the converse, inverse, and contrapositive statement. So let's take step by step in each parts. Converse statements. Here, when hypothesis and conclusion are switched or interchanged, it is termed as converse statement. The converse of P then Q is formed by interchanging the antecedent P with the consequent Q. It is notated as Q then P. The original statement switch positions in the original if-then statement. One of the examples of the converse statement is, if today is Monday, then yesterday was Sunday. The converse statement of this statement is, if yesterday was Sunday, then today is Monday. Here, the conditional statement logic is, if B, then A, wherein the original statement switch positions in the original if-then statement, which is A, then B. Inverse of statement. When both the hypothesis and conclusion of the conditional statement are negative, it is termed as an inverse of the statement. The inverse of P then Q is formed by negating the antecedent P and the negating Q. It assumes the opposite of each of the original statement and is notated as negating P then negating Q. Or, if not P, then it is not Q. Let us take the above example here. If today is Monday, then yesterday was Sunday. The inverse of this statement is, if today is not Monday, then yesterday was not Sunday. Here, the conditional statement logic is, if not A, then not B. It is when both the hypothesis and conclusion are negated. The if part of B is negated and the then part or Q is also negated.
On the other hand, the contrapositive of P then Q is formed by negating both the antecedent P and the consequent Q and interchanging this negated statement. The contrapositive statement is a proposition or theorem formed by contradicting both the hypothesis and conclusion of given proposition or theorem and interchanging if not B, then not A is the contrapositive of if A, then B.
Here is the example of contrapositive statement. If yesterday was not Sunday, then today is not Monday. It is when the hypothesis and conclusion are negative and simultaneously interchange. Then, the statement is contrapositive. Here, the conditional statement logic is, if not B, then not A. We must always remember that in the converse of statements, the converse of P then Q is formed by interchanging the antecedent P with the consequent Q. While in the inverse of the statement, the inverse of P then Q is formed by negating the antecedent P and the negating Q. And lastly, in the contrapositive statement, the contrapositive of P then Q is formed by negating both the antecedent P and the consequent Q and interchanging this negated statement.